Hey everyone, welcome to the Electric Supercar channel. This week we're going to be working on the Toyota. For those of you who are new, this is a 1987 Toyota Hilux pickup truck. We spent the last few months working on this one. We put in a Tesla Model 3 motor, we've got drive shafts installed, we've got battery boxes made, and now it's time to put them all together. If this is anything like my previous builds, we're going to have lots of troubleshooting this episode. Let's get to it. It occurs to me that in order for you to understand what we're trying to do, I need to describe what the plan is. For these electric builds, what we have is a motor, we have batteries, we have a controller, and a Precharge circuit. So for us, the motor controller controls the Precharge circuit. So what that does is the batteries have, say, like 400 volts, and when you close them, as they get really close, they can actually arc because there's a voltage potential. If you arc, it can actually kind of zap and weld it closed so you can't open it anymore. So again, we always want switches to open and close to keep things safe. What the Precharge circuit does to make it so it doesn't zap is it actually leaks a little current around, so basically both sides kind of get brought up to the same voltage, and that way when it closes, there's no zap. So basically what we're trying to do is we're trying to get our battery packs to close the contactors safely and deliver energy to the motor. It may sound easy, but there are lots of wires, lots of circuits, lots of fuses, relays, switches, all of these things that if anything's just slightly off, it can cause some issues. And usually those issues just result in a damaged component that can get pricey to replace all those. But safety is the name of the game. We want to make sure everything's safe. So I'm going to show you what we did with all the wiring and testing.
Okay, so we're working on the bottom of the Toyota here. I got that battery in there. We got to do some low voltage wiring. Some connections need to be made. We've got some cans, some power, and some things that have got to be wired to that battery. And then I think we actually have to add a couple of wires too that wasn't originally on the wiring diagram.
Russ is doing some of the final wiring. They actually laid this out on one of those wiring boards and did a lot of the wiring and actually put it on the car. So a lot of this is already done, but now they're just making all the connections that need to be made for the plugs and everything else. So you've got plugs are now populated. Just labeling, putting some of these last pins in.
I'm just glad Tony decided to be nice after lunch because he's been crabby all day.
It's going great.
Okay, so with any vehicle, you need to be able to turn it on. So what we've opted with here is a thumbprint scanner. So we have that all mounted in place, and the wiring is run through the original ignition switch. So we're gonna get this all put on, and we'll be able to test it. But I think it looks pretty good. You can even see it blinking like it's ready. Like that. And then you should be able to turn it on with your thumb. Turns green. So this is what it'll look like if your fingerprint isn't programmed in. So if you used a finger that's not programmed, it'll go red saying, nope.
We're now just making and installing the high voltage cables. Got one over here that we've made. Look how good that is. So we're just double, triple checking these cables. So we got that one there. So there's the motor plug. Again, the motor plug's also going there. We're just taking things slow, making sure we're getting everything connected correctly. Okay, we are on the final stretch. We're just actually connecting things to the 12-volt battery. Do we have an order of operations? Are we going to plug in everything at once? We're going to start off
Close contactor, full throttle, wheels on the ground.
We're gonna talk to the BMSs, make sure that they're all talking to each other.
Did you top it off with premium electrons?
We ran out of the premium. We got some mid-grade stuff.
Use diesel electrons? All right, we are so confident in our abilities that we're moving everything out of the way. So if we need to, we can just push it right out the garage door. That's how confident we are.
All right, hard crank.
So you just hooked it up?
Made a little bit of spark.
But we've got fingerprint start stop. We're gonna have Russ start it. We've got Tony up here for the emergency disconnect, but this is a first turn on of the car. So what should happen is when he starts it, we should hear a click for the negative contactor. A second later, we should hear a click for the positive contactor, and hopefully that's about it. We'll probably hear some pumps running like this power steering pump. That's about it, we hope. Now bets, you guys have any bets on what you think is gonna happen?
I think that we're gonna have issues talking with all the BMSs.
I think we'll get click click, and I think you're right. I think we'll have
I think
we'll have a communication problem with the BMS or T2C. Okay, if you guys are ready. I didn't hear any clicks. You guys hear any clicks?
I heard relay clicks.
The pump was loud enough that none of us were sure if we heard contactors or not. At least for now, it seems like we're able to communicate with the BMS, but we're not detecting things, which means I think there's 2 communication wires that might be switched. But we're gonna go ahead and turn it on again and see if we can hear contactors. I didn't hear any contactors. So I think that's T2C. So for a while we had no cells working, then we had 48 cells, and now we've got all 96. So Tony, do you want to kind of try to explain, I'll just say very simply, what happened?
Some of it was confusion on how things were labeled. So one's output is the other input and vice versa, and things were switched around. So
all right, so at this point I believe the battery management system is working. That's a pretty big milestone. So I'm gonna give a little shameless plug to a tool that I use all the time. I feel like everybody, if you don't have one, you should get one. It is the borescope. So it comes in this bag that's nice because you can just carry it wherever. It's really nice. Basically all it is, you got a little battery power here that gives you power. It's got a light, it's got the whole image, and then it articulates so you can kind of look around corners. To access files or to do charging, it's just here on the side, SD card, and then a USB-C. Also one cool feature about this one is it's got this little latch on the back. And this one you can like hang it, or you could prop it up just so you can see, kind of helps free up a hand. So on the back here, there is I'll call it a trigger, and that takes a picture. Or if you do a long press, it'll do a record. I can't tell you how many times before I had a tool like this, I would try and stick my phone and hit record and try and just blindly look where I was going, then hit stop and come back and look at the recording. This basically lets you do that kind of real time. One of the really cool things about this one is it actually has a camera that's sideways as well as out the front. I can actually toggle between them. So that one's the sideways one, and that's out the front. Well, actually that's both, and then you've got out the front. So again, this is really nice to see around corners and get to any spot you need to. So we'll just do a quick video to show you. So if I wanted to go through the firewall, the articulating head goes 210 degrees. So there are always uses that I need something like this for. So again, if I want to see kind of behind that battery box right there. So again, see, I can see those connectors. If we want to look to the side, so you can see we can look straight forward with this, or we push this button and you see both. This new one, it's got a smaller shaft, it's easier to go in places, it's got more range of motion so you can get to more places. And the dual camera, that's like amazing. A compact inspection camera designed to help you see inside tight, dark, and hard to reach places. It uses a slim 6mm probe with a 2-way bending camera head. That means you can maneuver around corners, behind obstacles, or inside narrow pipes with full control. The 4.3-inch IPS screen gives you a clear live view of exactly what the camera sees, and with 8 adjustable LED lights, you can inspect dark areas without losing visibility. It's perfect for checking engine cylinders, plumbing lines, wall cavities, or any space you don't want to open up or disassemble. You can capture photos and record videos with a single button, making documentation fast and simple. It's waterproof, oil-resistant, rechargeable, and portable, built for both home and professional use. Can't tell you how many times I've used something like this. So if you need something like this in your garage, I'll leave a link in the video description below. We're next gonna tackle the T2C things. All right, troubleshooting at its finest. We've discovered that our T2C was not plugged in. So that's why we didn't hear any contactors. So we are connected to the motor controller, not the motor. So we're still seeing zeros here. We're thinking that we don't have some of the termination resistors. And I'm still not sure if I'm hearing both contactors close. We are thinking that there is a, what does he say, negative contactor?
yeah, the negative contactor, low voltage that actually turns and clicks the negative contactor isn't populated.
Signal, yeah.
All right, so we haven't populated one of the pins on that. And so that one's got to go to the T2C, which is kind of in the cab.
Okay, plugging this back in. Where's the tank? Okay, so listen up. Like this, so I gotta. Okay, so people like this into this one.
All right, so I don't know if we're getting closer, but we are figuring some things out. So we're getting the Bluetooth from the T2C. So T2C is getting power. I put my head under where the T2C is so I can hear things clicking. So meaning I think it's giving signals, but those signals are not making it to the battery boxes. So troubleshooting continues. There is one wire here that seemed to be not quite connected. The other thing, we found a fuse that was needing replaced, but now we're gonna see if we can hear contactors. See, I can hear click, click in the cab. I don't hear it here. This is the way troubleshooting goes, but not there yet. We've found a couple issues, but even with those corrected, I still hear the click, click in the cab, which is the T2C trying to turn on those contactors, but for whatever reason, that power or a ground is not getting to those contactors to turn them on.
Okay, so part of the troubleshooting we got to do is we're actually going to go pin to pin with the T2C connector. I brought the motor connector up from around the door and I just have it kind of held and zip tied, retained. So we're going to go first after power. Switched power goes to E1, which that one's pinned into, and it goes to pin 3. Okay, so that works. Yep, unswitched, constant, violet. Okay, so we've got 12 volts on constant, check. Okay, so party can high, pin 30. Why do they call it party can? Okay, hang on. I think we might have a problem here. Why does it say on this pin 30 is a blue wire, but on this it says pin 30 is a white wire? Oh, okay, so we're already got a switched wire there, because that's supposed to be party can low. Let's see if party can high is switched with that, which is pin 20. Okay, so 2. Hold on, that's right. So 30 to pin 2, that is correct. Oh no. Okay, so those are switched. Alright, who the bed? Should do it. Okay, let's double check ourselves. Pin 30 goes to K2. Bing. Okay, then pin 20 goes to J2. That's a good noise. Okay, so it's got it. So check and check. That's amazing. Okay, I fixed it. No, my pronouns are the, she, and it.
All right, so we're just plugging in the last few things. So Tony, what were some of the things that you did to fix what's going on?
So the T2C, our EV controller, it needs like 3 switched ignitions. It has to have one that does the contactors, one that does like the reverse lights and some other things, and then a basic switched ignition. So we populated the last 2, and
so we had one populated, but not all 3.
Yeah, not all 3. So we got them all populated.
And then Russ, for you, what did you do?
So that we hadn't actually added our terminating resistors. You're supposed to have 120 ohm on each end of the CAN bus, and we didn't have any, so we populated those terminating resistors, and we should be able to talk to it now.
So we're gonna go plug this in. This is the kind of same thing as keyed switched on, so go for it. See, I feel like I only heard one. So if you scroll,
it says 1,024 volts
1,000?
right there.
Well, yeah, scroll down. Do you see other numbers? Anything that's not zeros?
High voltage bus, 1,024 volts.
Yes.
Max region.
region.
But we're not. So normally you'd see like stator temp, heat sink, stuff like that if it's communicating with the
Does
motor.
that need to be reflashed still though?
No, it should communicate without being reflashed.
Yay, 1,000 volts. We doubled our goals.
Yes.
We doubled it.
All right, we're just checking to make sure our high voltage, we're getting both packs connecting with contactors closing. All right, so we are getting into the nitty gritty details. We are just hearing one contactor. We opened the plug for the motor to verify that it was not getting pack voltage. And we're learning that one of the pins didn't seem quite seated. So when we're trying to do testing, as we kind of wiggled it, it would close the contactor. So we're looking and trying to reseat it.
Is it? Yes. Make sure you can get a good angle. You see all the shiny bits. Okay, so this one right here on this far edge is your positive contactor. The one in the middle is your negative contactor. And you can see it's not fully pushed in there.
Okay, so now we're going again. We're listening for 2 clicks. Ready? Click 1, click 2.
Yep.
Down here. So 340 volts. So we got that working. So when we do troubleshooting, we're always very sensitive. I'm gonna say nose sensitive and sound sensitive. If you hear something that's like, wait, what was that? We were around the car and we're like, oh, that just smells like something smells. And it turns out that the heater works.
Hold on, it's calibrating.
So yeah, so basically we swapped it out for essentially an electric heater, and the heater valve was like, or the heater knob was turned over. So we verified accidentally that the heater works. All right. No, still nothing.
Nothing.
So we're just checking out the CAN bus, seeing the messages we can read, making sure that we're communicating with the CAN bus. So it looks like everything's communicating. Trying to check a couple more things. T2C, so the motor controller, we believe has the wrong firmware. So it's firmware for a rear motor, not...
Rocket! Rocket! You done recording over here. You gotta stop. You gotta give it to them.
Okay, so we think we've got the wrong firmware for the T2C. We believe it's for the large drive unit for a Model S. We've got a drive unit from a Model 3. So we got to get new firmware, and I think that was the issue there because we've got all the wiring correct and we're actually seeing CAN data. So we have just, I think, successfully updated the firmware. So go ahead, let's hit back. So go down.
Inverter temp.
Yeah, so we got temps now, right?
Yeah, we do. Yeah, look at that.
So now we got temps and stuff.
So we're talking to the motor.
Boom.
Boom.
So that's a great success. We're in the middle of troubleshooting.
Austin, stop clapping. Austin.
He's okay. He's okay. We're in the middle of troubleshooting. So we got a couple issues. We've lost our high voltage, so we think maybe a fuse is blown. We're going to take the access panel off the rear battery pack to see if we can check that out. The other thing is we had our BMS in there and everything was working, but we got one, I'll call it glitchy cell, and we've seen this before. So I think the only way to kind of really address it is to take the pack out, open it up, and redo a wire. So never easy, but I think we're on a path that will lead us to success. All right, we are in the process of taking out the front battery box. All right, we got this guy back out. We have determined we still have a full pack voltage, but the fuse is right there. Not hard to see, but the fuse is blown. So we're going to try and figure out what made the fuse blow, but we'll replace that fuse. And then we had one cell tap. So we're still digging in, but the cell tap's going to be right around here that we're going to redo as well because it was intermittent.
We were going over a couple of things. During the process, we found the wires get a little tight, but they're coming through a spot where it's tight, and it's a sharp corner, and a sharp corner on wires means we're going to be back in the battery box unless we resolve it now. So I can show you the wires coming out are inside of here on the back side of this. It says they come out right in here. Just this sharp edge on the back side is where these wires are coming out. And it is starting to pull on some of the tape. To get to that, I got to pull these main components off. So we got to get this off, this contactor off, and then we got to get access to that. And we'll clean up the edge, make it a little rounder, a little softer for wires. Got to hand it to Jeremy. His connector game is good. Boom, and it's out. Okay, that's the plate. Problem is that edge is pretty sharp, and let's be honest, we're a little tight here. So we're gonna open that up and give all of these wires a little bit of breathing room.
Okay, so I got this plate off, and I was able to get a nice round edge on there. That's the idea, so we'll get that slammed back on.
And then we'll clean this off so it doesn't look like a big mess. Look around there, it should be nice and cleaned up. Doesn't look super weird or messy.
All right, so see, we just keep on getting this bumping between low voltage condition, high voltage condition, and returning to okay. So I've had this before, and usually what it means is kind of a loose connection or a pinched wire. So we're gonna go ahead and replace those ones. All right, so we've replaced the fuse. There's also one of the contactors that was stuck closed, so we replaced both those. We're now buttoning back up, and we'll kind of probably just wheel it over to the Toyota and turn things on sequentially, like one at a time. So if something does happen again, we'll know what was the cause. All right, so this one, we've got the cell tap wires back. We've got essentially all the components put back in place, a new fuse. So this one's ready to button up, but we're not going to button up. We're just going to roll it in place so we can test things. All right, so we've gone through the battery boxes, taken out some of the fuses that were bad, put new fuses in, kind of done a couple other checks. We didn't really see anything that would blow big fuses, but yeah, I think our plan is we're gonna just take everything kind of sequentially. So right now, we're not gonna even install the battery boxes. We're just gonna put them underneath, and that will allow us to kind of do all the connect. We're gonna connect the two battery packs together with high voltage. Then we're gonna connect the low voltage, the things that make the contactors and things go. We'll start the vehicle. So no other high voltage is going. It's like not to the motor, not to any of the other components, just the packs themselves. So if that goes good, then we'll start adding some of the other components like motor and things like that and see if we're still looking good. You agree we're good to turn on? Okay, well, we're gonna try. So ready? 3, 2, 1. Everything looking okay, nice and cool. All right, so we closed contactors. Again, no high voltage is connected. We thought we might as well start easy. We've got the thermal camera going just to make sure we don't have anything getting hot. All right, checking in with the BMS. We are reading all the voltages. If you remember before, we were kind of getting some fluctuations right here around cell 50. That seems to be gone. And again, they're all really tightly grouped. I mean, 3.58. So far, so good. No blown fuses. Everything seemed to complete the circuits as we thought. BMS looks good. So we turned the car off. Now we're going to connect high voltage just between the packs and go again. 3, 2, 1. So all the cells are still looking good.
Looks good. Only like 26, 22, 27.
So it's looking good. So those are the BMS modules. And this is the front one. We've got a contactor on. We got 2 contactors on. So far, so good. I think the next thing we're gonna do is we're gonna try plugging the motor. I think that's the next most likely thing. If we had any issues, it'd be due to the motor. So got car off right now. We're gonna plug in the motor and do it all again. All right, we are going to be putting in the high voltage cable from the battery box to the motor. Again, all systems are off right now. Okay, 3, 2, 1. I'm turning off. I think that sounded like a fuse again.
There was so much inrush current, this jumped.
All right, so we did pop a fuse again. It was a one in the front battery box. So again, we did things nice and slow, methodically, so we know it's basically when we connected the motor. I think the only thing we can think of is if somehow we've misunderstood things and the motor leads are switched. Either that or it's just a dead short in the motor, like it's a bad motor. So we'll keep looking and let you know. All right, so swapped out for a new fuse, swapped the leads for the motor. We're gonna slowly start again. It's now on to connecting the motor cable and trying again. Oh, go. There it goes. Okay, we're gonna turn on. No blown fuse, no blown fuse. Please, no blown fuse. Okay, ready? Ready. 3, 2, 1. Click. Damn it. Didn't that sound like a fuse?
Whoa, that was way louder than last time.
What is wrong? All right, we thought we had blown more fuses, but it turns out we just welded contactors. I don't know that that's any better. I think that's probably worse because they're a little more expensive. What we're finding though is, for whatever reason, our Precharge resistor here is not getting any resistance. So when we check it, it's like literally at 0, like it's
No continuity.
like no continuity. We do have a spare, but that also means we need to dig out contactors. So one in the front, one in the back are both stuck. So yeah, man, that resistor's bad. It is late in the day. We have replaced the resistor that was bad. We did some testing with the Precharge circuit, replaced the, what do you call those, contactors. So contactors should be good, Precharge should be good, everything should be good. We're gonna test it first without the motor, and then we'll try it again with the motor. So far, so good. Relays all opened and closed, no fuses blew. So we're hooking up the motor cable. I've been calling it the death cable because killing a lot of components, but hopefully this time it's got it. Okay, death cable's on. If this just pops again, I'm just gonna swear and go home. And if it doesn't pop, then I'm gonna say yay and go home. 3, 2, 1. No pop. That sounded okay, right?
That sounds great.
All right, so we didn't hear any pops this time. Just checking quick with the thermal camera. Well, we were close. We thought we had it, but all the clicking noises were made, but we didn't get high voltage to the motor. So for whatever reason, the negative contactor is actually making a clicking sound. We verified that we've got the signal. We actually unplugged it and did a power to it and actually got it to click, but it does not make continuity when it clicks. So we're gonna replace that one. Then we'll be a little bit closer, hopefully. That was the contactor we needed to replace, so it's now been replaced. I believe we're now good to try again. We'll see what goes wrong next. Yeah, this is all getting kind of unkempt again, so once this is working, we'll spend some time and clean up the wires. So we've got everything set again. I'm gonna turn it on, again, without the motor connected, and just make sure that all the systems seem like they're going correctly. Okay, that sounded okay. Let's do some testing. Okay, fuse is good. That contactor's good. That one is not, so we got to replace a contactor. We replaced this contactor, I think we need to replace the other one. So contactor switch out, test things again, so we're gonna try one more time. Again, motor's not connected, but everything else is. So let's see if we can get this thing to at least get that far. Okay, it sounded okay. Let's look at it. All right, so that's good, 344. Yep. Okay, that's looking good. We will connect the motor cable and try again. All right, we now plugged in the motor cable. Gonna try it again. This is the part where we've struggled. We've kind of blown fuses, welded contactors. I just try to keep thinking through things, but we'll give it a try. Didn't sound too bad. So we do have high voltage going to the motor. I think that's as far as we've ever gotten. Yeah, I think we're good. Guess I should get the thermal camera and make sure. So nothing's looking very warm over here. I think, cross your fingers, we got most of the difficult things out of the way. I am gonna see if we've got things hooked up enough to see if we can get the motor to spin. So all we need is a brake signal and the accelerator pedal. And I can't remember if we've wired those. So I see wires to them, I just don't know if they're going to the controller or not. So we'll do a quick evaluation. If we've got those, we'll get the motor to spin. If not, that'll be for next time. Here is the iPad display that shows us everything. What we're looking for is there is a grayed out button right there that says brake regen. So if we step on the brake pedal, we're hoping that goes red. If not, that means we don't have it wired correctly. The other one is right there, accelerator pedal. It's right there at 0. So again, if we push it, we should hopefully see some numbers populate. If not, that also means it's not done correctly. So let's check real quick. All right, so we got foot in position. Again, come on, red. So I can hear the switch, but I don't see any red light there. So that means we're not gonna be able to go into drive. Let's check the accelerator pedal. So accelerator pedal. So we get an accelerator pedal, we just need brake switch. All right, this build more than most, I think we did a lot of bench testing. Even with all that bench testing, we still had to take things apart. I think the two things that we learned for this one is we didn't test our Precharge resistor. That one seemed to be bad. And the other thing is we probably didn't do enough due diligence or enough checking on the motor wire because that one got reversed. Needless to say though, we got those figured out. It was a little more pricey to fix all those things, but we've got it. Next time we will get the motor spinning and hopefully we'll button everything back up. And then it'll be ready for the first drive. Thanks for tuning in. See you next time.
My wife and I had a talk and we decided that it's okay that Braden's my hall pass.
That was the weirdest thing I've heard all day.
That's not that weird.
That's not that weird.
You should hear, does he get uncomfortable when I tell him that he's my hall pass? He's got stunning man features.
Don't say it like that.
What? He does.